Number 36. Tammy leaves home and drives 85 miles in 1 hour, 35 minutes, and 54 seconds. She increases her velocity by 8.1% and returns home. What was her driving time on the return? So I'm going to start off by finding her initial speed in miles per hour, which I can do just using the formula distance equals rate times time. So if distance equals rate times time, then rate equals distance over time. And let's see, we know the distance is 85 miles. That wasn't supposed to happen. The distance is 85 miles. And then the time, well, our final answer is in hours. So I'm going to go ahead and convert this to hours. So if I do that, that's 1 plus 35 over 60 plus 54 over 3600. So I'm going to go to my calculator and find what that value is real quick. So 85 over 1 plus, and then I forgot the other stuff, 35 minutes 54 seconds. 35 minutes 54 seconds. So this comes out to roughly 53.2 miles per hour. All right, so what they do next is they increase their velocity by 8.1%. So to do that, all I have to do is multiply by 1.081. This will increase this value by 8.1%. And so I get a speed of 57.488 miles per hour. Let's see what they're actually asking for, though. It says, what was her driving time on the return? Okay, so we just have to use this formula again. So we're looking for hours. So in that case, time would be distance over rate. So it would be 85 miles over however many miles per hour we had from before, 57.488 miles per hour. And that should give us hours. So we do 85 divided by that value here. So we get 1.4785 hours. Now, this problem is actually a significant digit problem, which means it's not necessarily 3 significant figures. And in the answer key, it says we have 4 significant figures. And I'm honestly not sure how they got that. But the way that I see it is, here you have 85 miles, that's 2 significant figures. This is 8.1%, that's 2 significant figures. It makes sense to me they would be 2, but the answer key says 4. If anyone knows why, please tell me in the comments, because I truly have no idea where they got 4. But I'm just going to go with it. So with 4 significant digits, it's 1.479 hours. Alright, now for number 37. Let's see, what do we have here? Number 37. So Wanda cuts a piece of 25-inch long string into 2 pieces. She forms a square with one and a circle with the other. The combined area is 25 square inches. If the circle area is larger than the square area, what is the circle diameter? Alright, so at the end of the day, this is pretty much just a solver question with geometry. It's just a little bit more complicated. So you have a 25-inch long string, so I'm going to say the first bit is x inches, and the second bit is 25 minus x inches. So together, that's 25 inches. So she forms a square with one of them, so I'm going to say this is the one for the square, and forms a circle with the other. And then the combined area is 25 square inches. So we just have to find the areas of each of these in terms of x, and then we can just solve for x. So for the square, to find the area of a square, you have to take the side length and square it. Well, this length, if you think about it, will correspond with, it will be analogous to the perimeter. So the side length of the square will actually be x over 4. And then to find the area of that, it's just that squared. And then same kind of logic with the circle. This 25 minus x will really be the circumference. And so to find the radius there, I have to divide by 2 pi. And then the area of a circle is pi r squared. So it'll be pi times 25x, pi times 25 minus x over 2 pi squared. And together, this will give us 25 square inches. So I'm going to put this in my calculator solver and see what we get. So many 3, 1, x over 4 squared plus pi times 25 minus x over 2 pi squared. This gives us 25. We want to find the length of the amount of string they cut off. So for x, we get two possible values. We get 9.315, or what's the other one we get? 9.315 or 18.689. Now the question is, which one do we use? So right here, it says if the circle area is larger than the square area. So what I'm going to do is just take one of these numbers. I'm just going to pick the 9.315. And I'm going to plug them into each of these equations for the area. And if it turns out that the circle area is larger than the square area, we'll use 9.315. If it's the other way around, we'll use the 18.689. So for the square, we'll have x over 4 squared. So that will be 9.315 over 4 squared. So that's the square area. And then the circle area is pi times 25 minus x over 2 pi. So 25 minus 9.315 over 2 pi squared. Yes, and so we get 19.57 for the circle area. So it looks like the circle area is larger than the square area. Is that what it wanted? The circle area is larger than the square area. Yes. So now we need to find the circle's diameter. So we know that x is 9.315. Now to find the circle's diameter, well, we know the circle's circumference is 25 minus x, which means 25 minus 9.315. So that gives us a circumference of 15.685. And then if we want to find the diameter, circumference is just pi times the diameter. So I'm just going to divide this by pi. So we get a diameter of 4.99. 4.99 inches. Always check this unit at the end, because a lot of times you'll spend a lot of time solving a question only for them to switch out the units on you at the very end. And let me tell you, it's pretty annoying. Okay, last one, number 38. Let me erase this real quick. Now, this one you need a little bit of knowledge that you may not have had, but it's pretty straightforward once you get it. So, let's see, the mass of a raindrop is 0.034 grams. I think it's supposed to say how many. How many drops fall into a rain gauge with a cross-sectional area of 1 square inch during a 2-inch downpour? So let's see. Let's find the total volume of the rain that fell. So if you have a 1-inch base and a 2-inch height, then together the total volume that fell is going to be 2 cubic inches. Now, for the piece of information that you're going to need, you need to know that the density of water is 1 gram per cubic centimeter. So I need to convert this 2 cubic inches to cubic centimeters. And the way I'm going to do that, I'm just going to use some dimensional analysis. I have 1 cubic inch on the bottom and 2.54 cubic inches on top, because there's 2.54 centimeters in 1 inch. If I do this, 2 times 2.54 to the third power, I get 32.77 cubic centimeters. So let's see, what do we do with this? The mass of the raindrop is 0.034 grams, and we get a total volume of 32.77 cubic centimeters. So, if the density of water is 1 gram per cubic centimeter, and we have 32.77 cubic centimeters, that means that the total mass is also just going to be 32.77 grams, since it's a 1-to-1. You have 1 gram per cubic centimeter. So if the mass of all the water that fell was 32.77 grams, and each raindrop is 0.034 grams, then to find the total number of raindrops, we can just divide. So it'll be 32.77 grams total divided by 0.034 grams per raindrop. If we do this, we get a value of 964 raindrops. So 964 raindrops. All right, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I'll see you next time.